So we've all seen the headlines, right? An AI can just crush the world's best players at their own game. But here's the thing. When we see an AI dominate like that, are we looking at actual intelligence, or is it just a souped-up calculator doing its thing? That's exactly what we're going to get into today. I mean, think about it. From the chessboard to these massive, complex video game worlds, AI is performing at a level that's just, well, superhuman. It feels like this new kind of mind is emerging, something that can out-strategize and outplay even the most brilliant humans. It's pretty impressive and honestly, maybe a little bit intimidating. But, and this is the big but, does being amazing at one thing really mean you're intelligent? I mean, really? That's the question at the heart of all this, and believe me, the answer could completely flip how you think about AI. All right, so first things first, let's take a quick look at the highlight reel. Those huge wins that made everyone think AI was on this unstoppable march toward becoming a genius. And wow, what a timeline it is. It really kicked off back in '97, right? When IBM's Deep Blue beat Garry Kasparov at chess. That was a huge moment. Then, fast forward to 2016, and AlphaGo defeats the world champion at Go, a game so complex people thought it would take decades longer for an AI to master. And it didn't stop there. By 2019, AI is just dominating super complex games like StarCraft 2 and Dota 2. We're talking about environments with way more moving parts than any board game. With every win, it looks like AI was climbing another rung on the intelligence ladder. Okay, but this is where the plot thickens. Because when you actually peel back the layers and look at how the AI was winning, that perfect picture of intelligence, it starts to get a little fuzzy. You start to see the cracks. Yeah, there's actually a name for this. It's called the AI effect. It's this funny thing we do. As soon as a computer gets good at something we thought was a sign of intelligence, like chess, we immediately go, oh, well, that's not real thinking. But it's not just us being difficult. It points to something deeper. We're getting mixed up. We're looking at the shiny, skilled final product, and we're forgetting about the messy, intelligent process a person goes through to get there. And this confusion really comes down to two totally different ways of looking at intelligence itself. Is it just having a giant collection of specialized skills, like a toolbox full of very specific tools, or is it something more general, a flexible ability to learn, to take whatever life throws at you and turn it into new skills for problems you've never even seen before? For a long, long time, AI research was all about that first idea, building the biggest toolbox. And this right here, this perfectly shows the problem with that approach. To get that superhuman skill, these AIs don't really learn like we do. They just use brute force. Get this. One of the AIs that beat the top Dota 2 players was trained on what amounts to 45,000 years of gameplay. Can you even wrap your head around that? It didn't outsmart people, it just outpracticed them by an amount that is literally impossible for a human. But here's the real kicker. Even after all that training, these systems can be super brittle. So when that Dota 2 AI was released to the public, you know what happened? Regular players, just messing around, came up with creative new strategies the AI had never seen before, and they beat it. It was a god in its own little world, but the second you threw a real curveball at it, it shattered. It had skill for sure, but zero adaptability. So all of this leads us to a totally new way of thinking, a perspective from AI researcher François Chollet that might just change the game. It's got completely reframing what we're even trying to do, moving the goalposts away from just raw performance. Here's the idea in a nutshell. Real intelligence isn't about the skills you've already mastered. It's all about how efficiently you can learn new ones. Let me say that again. It's about the efficiency of learning. So if you and I have the same amount of experience, who can learn to solve a bunch of new problems faster and better? That's the true test of intelligence. And thinking this way just changes everything for AI research. Suddenly, the focus isn't on a specific skill, it's on a general ability to learn. The method isn't throwing mountains of data at a problem, it's about learning efficiently. And what you're trying to build is no longer a one-trick pony, a savant for a single task, but a learner that's flexible and can adapt to anything. So here's the main idea to hold on to. The real magic isn't the finished product, the AI that can play chess. The magic is in the process. It's the underlying system that can learn chess and then turn around and learn something totally new with the same kind of efficiency a human has. The intelligence is the engine, not just one of the cars it happens to build. Okay, so if just looking at performance is the wrong way to go,
How on earth do you test for this skill acquisition efficiency? Well, turns out you need a totally new kind of test. And that's where something called the Abstraction and Reasoning Corpus, or just ARC for short, comes in. It's a test built from the ground up to measure that flexible, human-like problem solving, not just how good you are at a game you've already practiced. So here's how an ARC puzzle works. It's actually pretty simple. You get shown a couple of before and after pictures, these little grids. Your job is to look at those few examples and figure out the pattern, the abstract rule that turns the before into the after. Then you get a new before grid and you have to apply that rule to get the right after. It's all about figuring things out from just a little bit of information. Let's try a quick mental one. Imagine the rule is something like, find the biggest shape in the grid and make it the same color as the smallest shape. You see one or two examples of that happening. Now I give you a brand new grid. Could you do it? Could you apply that rule? That's exactly what ARC does. It forces you to generalize, to find the big picture idea from just a few clues, which is something we humans are amazing at. And that's what makes ARC a totally different beast. Think about it. A video game is a known quantity. You can practice it for, 45,000 years and eventually solve it with data. That measures skill. ARC is the complete opposite. Every single puzzle is brand new. You can't prepare for it. You only get a handful of examples to learn from. It's not measuring skill, it's measuring how fast you learn. And here's a really smart part of the design. To make sure it's a fair fight between a human and an AI, ARC is built on what scientists call core knowledge. These are the basic ideas we humans just seem to get right from the start. Things like objects are solid, some basic counting, and how shapes fit together. By sticking to these universal concepts, the test gets rid of any cultural knowledge you'd learn in school, creating a truly level playing field.
So what's the big deal? Why does any of this matter? Shifting from performance to learning efficiency, who cares? Well, you should, because this isn't just some nerdy debate for researchers. This could be the spark for the next big revolution in AI.
Okay, let's just quickly recap the main takeaways here. First, focusing only on skill gave us AIs that are powerful, sure, but also brittle and need insane amounts of data. Second, the real measure of intelligence is how efficiently you learn new things. Third, to test that, we need new tools like ARC that are all about learning from a few examples. And finally, the ultimate goal has changed. We're not just trying to build a master performer, we're trying to build a master learner, something with the amazing flexibility of a little kid. Look, we already know what an AI that's a master of games can do. It's impressive. But just take a second and imagine, what could we accomplish with an AI that's a master of learning? An AI that doesn't just perform, but truly understands how to learn anything. What kind of problems could we finally solve with that?